Hello, today we are going to do this problem from Leetcode Daily Challenge. Number of ways to form a target string given a dictionary. So basically we have a list of strings that have the same length. And those are in words array, and we have a target string. And our task is to form this target string using the words in this list. But we have to follow some rules. So the first one is that targets needs to be formed from left to right, so it's not random. And then if we take an ith character, if for the ith character from target, we take, because it matches, we take the kth characters from one of the words, then all the characters to the left of that one, to the left of this kth character in the same word, we can't take them anymore. That's actually this third rule. So if we take the kth characters from a word, then we can no longer take anything to its left. And this one basically just tells us that the target at that index, right, needs to match the character we are taking from the word, which makes sense. And it says here we can use multiple characters from the same string, right? So for example, this one you could use 3 B's, you could use A, C, C from this one. So you could use multiple characters from the same word. And what we want to do is to return the number of ways we can get target, which is this string, out of the list of the words. And of course, we want to use a modulo here. Okay, so that makes sense. Now, for example, if we take a look at this first example, what we can do is first, there are a couple of ways we can do it. First is taking this A to match this A, and then taking this B to match this B, and then this A to match this A. The other way of doing it is for this final A, you could take also this A. Another way of doing it is for that final A, you can take instead this A. Again, another way of doing it, instead of taking this B, you could take this B or this B or this B, right? So you see there are multiple choices, and if we compute all the number of ways, we have 6 overall. So that's the idea. Now, in terms of limits, we have all the characters are lowercase English letters. Target can be up to 1,000. The words themselves can be up to 1,000 as well, and the number of words can be up to 1,000. So it should be reasonable if we do something that tries all possibilities. It should be able to fit. So let's see how we can tackle it. Okay, so how do we tackle this? Well, the first thing to note again with all of these problems is to think if there is some approach we can use to do this in a greedy way without trying all possibilities, or any other approach we can do that doesn't require us to try all possible options, basically to try all the combinations of characters of each word and see if we get target. And there is not really anything, right? We have to check the character to see if it matches a character in target, and so immediately we should try then to think about if we can do it with just trying all possible choices. Okay, so thinking about all possible choices, what can we do? We have target, which is ABA, right? We of course need to go through this target characters one by one to find a match, right? And so in sort of these choices, we need to think about what state are we choosing with, right? So here, definitely one of the choices is the target index. One of the things is so basically, if we find a match, we will move target. Let's say if we found a match for A, so we found an A like here, we'll move target index to B. If we find a match to B like here, we'll move the target index to A. So we definitely can move with that. And so we need the target index to tell us where we are at the target string. The other thing we probably need is we can either go through the words, and in that case we need the index of the word, but we also need to know where did we stop at each word, because the problem says if you, for example, find a match for this C, you no longer can use these two. You can no longer use these two because they are before it. So when you find a match, you can no longer use anything to the left of it. And so if we use word by word, then we need to also maintain the index we stopped at. Let's call it J here. So we need to tell the next word, the next iteration, that we can pick only from this position j+1. Okay, and that's actually a little bit tricky. So let's first think about if we can do it differently, because that's tricky. So the way we can think, and also tricky, and it would be expensive because we would have 3 values for our state. So let's see, if we put the words like next to each other like this, then we should be able to think about something. So these are the indices of each word. The words have the same length, right? So actually what we need is, let's say we have an A here. So for example, here we have an A. How many ways can we get an A from this first index? Well, there is only this one. And so there's only one way with the index 0. For this index, there is only one way with this one. For this index, last one, there are 2 ways to get an A. And so, for example, if we want to match this last one, we know we can match it in 2 ways. So that tells you that the frequency matters here. We can use the frequency in some way. So that's the first intuition. The second intuition is that, well, let's just actually, since we only need to compare the for a single index, we can compare for all the words we have and just check how many we can match, right? And so we just need to pass the actual column index for the words. So let's just consider the words as rows, and then let's just pass the index. Let's call it I as our state. And now what are the choices we have? And now our choices become, at each point we have, either we can find a match for target index or no match. Okay, so if there is no match, well, what's the next state? Then the next state is just going to the next column. So if there is no match here, let's say if this was X, there is no match, we can just go to the next column, which is I+1, and the target index stays the same. I will call it T index, just abbreviation here. Target index stays the same, and this called DX index. Target index stays the same, and we move to the next column. Now, if there is a match, what does that mean? Well, it definitely means that the next state is going to be we go to the next column because we already used the matches from the current column. We can't use anything to the left anymore. So we have to go to I+1. But we also need to update our target index because we just found the match. It's good, we move our target index to find the match for the next one. Okay, so this is the states we do, but by how much we should add the number of ways? Remember, we are calculating the number of ways. So this here, the number of ways is just going to be there, but here, by how much should we add? So here we just add the next state, but here, how much else we should add? Well, let's say, for example, we find a match for this. Let's say we had another A here, and we found 2 matches here. And we are now looking for matches for B. And let's say for BA, we find 3 ways to get BA. And here we found 2 A's. How many ways overall we can get total? 2 multiplied by 3, 6, right? Because each of these 3, you can associate it with each of these 2, and that will give you 6 combinations. And so here, this actually, if we sort of call our recursive function, if we call it ways, then this ways function here, whatever we get from it, we multiply by how many matches we got. So the matches for target at target index. Okay? And then we add that to our result. And then we add this also to our result, because remember, it's the number of ways, so we need to add the number of ways for all the combinations, for all the choices. Okay? And so now we know the choices we can do, so we can just do recursion there. But now the question becomes, what do we do to calculate this? We can definitely calculate it each time, but it's easier to just pre-calculate, and we can use either a map or a table to just calculate for each character how many times it occurs in each index, right? And that's since we have only lowercase English letters, we have only 26 character, so we can have some sort of occurrence array, right, that has the index as the row, so the index here as the first index will just tell us how many occurrences of each character in this column for this index, right? And then the value here would be just for the character, which we can just use ORD to get for a single character to get the representation in 26 range, like this. And that should be pretty much it. Okay, so let's run it actually on an example just to make sure we understood this. So if we copy this here, go here, quickly run it on an example. So the first state we'll start with is we have, of course, target is still ABA. So the first state is going to be target is 0 and the column 0. Okay, and our column, by the way, ACA, BBBB, CACA, and this is 0, 1, 2, 3. Okay, so here we have two choices, right? We can either look for matches for this A or not look. So first choice is not look. Well, we'll just go to the next column, and we are still at index 0 for target. The second case is, well, there is one match for this A, right? So we know here we have one way definitely, and then the next state is going to be the next column, which is 1, and then the next target character, which is 1. Okay, and now here, why is it 1? To multiply by whatever the number of ways we get from this, because there is only one occurrence of A that matches here. Okay, so now for this, for example, if we go down again, we have two choices. We can either go to the next column and still stay at 1, or we can go to the next column, but can we move by 1 here? Well, it depends if there is occurrences of B in this column. Well, there is 1 here. And so we can move, and so 2. And by how much we multiply? Well, we have just one occurrence of B, so we multiply by just 1. There is one way, just one way to get here. Okay, so we continue again, 2, 2. So can we take this A? Is there a match in column 2? There is no match, so we only have one choice, which is no match choice. And so no match choice means we go to 3, column 3, and then which is index 3, and then 2, still 2. And so now at this point we look here, is there a match for this A? There are actually 2 A's here. And so here we go with 4, so we are done. So this is actually base case because we reached the end, but we multiply by 2 because we found 2 occurrences, which means there are 2 ways. Okay, and so if we bubble this up in this branch, we have only 2 ways because we multiply and multiply. We have 2 ways, and the parent can add up all the branches. This branch also returns something, and this parent will add it up and return it to its parent. And so the base case you saw here is both can be, we have 2 base cases. One, if we reach the end of target, then we are good. We should count that as a way. So if basically target index is equal to the length of target, then we should count that as one number of way. But if it's only, let's say here maybe we reach 3, 1, okay, then we didn't find matches for all the target, but here we reached the end of the words of the columns, and so here we return 0 because it's not possible. So those are the base cases, but this is sort of the structure of branching that will happen. Yeah, and that's pretty much it. This should give us a solution. We can just recurse using these 2 choices, and then we can build this occurrences array and use that here, and that will simplify the calculation for us, right? And each time we'll multiply by the number of ways we can get because of the number of characters the number of characters that match that we can get from each column. Yeah, so that's pretty much the idea. Let's code it up and make sure it passes. Okay, so now let's implement this solution. So the first thing we need is definitely our function, which is ways, and we said the 2 indexes we need is the index of the column and or the index in the words and the target index. Let's call it target index. And we said the base case is if this reaches the end of target, then it's a good solution, and so we need to count it. But if we just reached the end of the words, but we didn't find we didn't match all the characters of target, then we are not able to construct it. And so we need to return 0 in this case. Sorry, this is the length of words 0 because words have the same length, and this is the number of characters in the words, okay? And now here we have two choices. One is skip, right? And the other is, you could call it consider or take or whatever you want to, yeah. Or take if you can, right? Take if you can. That's sort of what we are doing here. So for the skip, it's easy. So we'd have our result. This basically will start out as 0, and we will add each choice to it. And so we'll return it at the end here. And so here for the skip, well, we want to add just skipping to the next column, right? So it's going to be I plus 1, but still same target index because we didn't find any matches. And then here we'll add ways. We'll skip to the next column again. And then this is going to be index plus 1, right? Because we need to find a match, but we need to multiply it by the occurrence here. So we'll create the array shortly. So this is the occurrence of what is the character? Well, the character is just the character in target. So it's going to be target at t index. And then this is what we will use here to get the index in this array. This is just will give us the index in the lowercase alphabet list, okay? And so if the character is not there, we'll multiply this by 0, and so this will not add anything, which is what should happen, because if there is no match, we shouldn't take it, and so that's why this works. Let's actually create this occurrence array. So it's going to be 0 for each lowercase initially, but we want to do it for each index, for each column. And so that's going to be range of the length of the words 0, because words have the same length. This is the number of columns. You could also call it just columns like this, and that way we can just reuse it here. Okay. And now to calculate it, we will just go through every word and then enumerate all the characters in every word. Because remember, this is the column index and this is the character. Let's call it like that. In enumerate of W of the word. And then for the character, so we put the column and then the character. We of course need to do the same thing here to get its representation in an index. So that would be something like this, minus the odd for A. And we will plus 1 because it's in this column, right? And then we will start our recursive call. Well, what's the start state? Well, we start from the first column and from the first character of target, and then that's what we want to return. But we also want to apply the mod that the problem says we need to apply, and so we can just take a mod like that. This is going to be our mod, 10 to the power of 9 plus 7. We apply the mod here, and then we also need to apply the mod here. And that should be it, pretty much. Except, of course, this has repetitive, calls this multiple times and recalculate, so we'll need to memorize. But first, let's run it. Looks good. Let's add memoization here. So we just need a map. And then we need to check if it's present. So if these two in this state are already present, we want to just return them. So I and the target index. Now, if they are not there, we just want to set them before returning, and then we can just return. Okay, so this should work. Let's submit. And this passes our test cases. Yeah, so that's pretty much it. Just trying all the different ways, and then using memorization. And the main trick is to think about it in terms of columns for the words, and then using this table to record the occurrences so that you can easily calculate the number of ways that we obtain from each match. yeah, so that's pretty much it. Thanks for watching and see you on the next one. Bye.